Yeah, I think we are live now. So yeah, just a minute. GitHub. Hi, Happy Life. Can you just confirm that the audio is good? I've been facing some issue with my mic. If you can, Okay, Gnandaryo. I think my audio is fine. Okay. Okay, so let's start. Yeah. Okay. Okay, so let's start with today's session. So my main motive for this live session is to make you aware of retrieval augmented generation. Retrieval augmented generation is a buzzword these days because it lets you talk to any kind of documents very easily and in most cases very efficiently as well. So let's first understand the different component of retrieval augmented generation. So basically what we are doing is that we have a document, we process the document, then we chunk the big document into small pieces or small chunks and then convert those chunks into numbers, and we store that numbers or those numbers in a data store. This data store is not the simple one or the usual data store. It's a kind of a data store where you can store large vectors or list of numbers, floating point numbers, and that data store also allows a facility to search or find similar vectors or list of floating point numbers from the large data. So that's why those kind of data store are known as vector DB. Then what we do is that with the help of large language model or Openai in more broad sense, we try to generate response from the vector. So let's understand. I'm sure we are okay with everything. Yeah. Okay. So yeah, I think we are okay. Okay, so let's understand the whole flow chart, how this is going to work. Let's say user writes something. So this can be any platform, website, WhatsApp, Telegram, Facebook Messenger, any platform. Also, we will consider the fact that we have a facility to save all the message. Facility to save all the messages. Okay, when we talk about this, I'm assuming that we have facility to save all the messages and retrieve as well. Save and retrieve. Okay, we have a facility to save and retrieve users message efficiently. So what happens is that user writes something on the channel. Now I hope you understand, channel can be anything, any communication channel, which allows two things. First, it lets us know that a new message has arrived, and second, it has a facility to send message from a computer software or program. So any communication which has the two things, on that channel user writes a message. Now we have a facility to save and retrieve all the messages. So when user writes a new message, we retrieve all the previous message. Let's say we retrieve past 5 messages. So what happens that we have now query and chat history of last 5 conversations. So the next step we will do is that we get the query, rephrase the question. Now this can be a tricky part to understand why rephrase the question, and the reason behind it is many times, let's say we are in a conversation where user has asked something, the bot has replied with something. Now user says yes, only yes. So at that point it is very ambiguous to search yes keyword in the vector database. So that's why we rephrase the question so that it can be formed in a way that is very helpful to search in VectorDB. Now just halt here that we rephrase the question. Now let me come back to this for element 1 2 3 4. We have documents. We process the document and extract text from the documents or document, then convert that into embeddings. That is nothing but vector or let's say list of numbers representing the part of text, obviously. And then we save the embedding and the piece of text which is represented by the embedding into vector store. Now this part is clear, I guess. In case you have any question for all the community members, in case you have question, you can send those questions to my WhatsApp, cause or you can write question here. I'll frequently looking into the chat section. I don't have two screens, otherwise two screens, otherwise I would have done that. So yeah, so this part is clear, I guess. Documents, we process that, convert embedding and save the piece of document and embedding into vector store. Now we resume from here. So we have rephrased the question. With the rephrased question, we convert that into again embedding the same way we have done that, and then search into the VectorDB. So VectorDB will return us, let's say 3, 4, 5 similar documents. With the help of those similar documents, we create our context. Now we have 3 things: query, previous chat history, and the context which has useful information about the query. Then we do some prompt engineering. We define a system prompt. Let's say you are a helpful assistant and use the context and chat history and query to answer users question, and append context, chat history and query into the prompt. And with the help of these 4 elements, we pass these 4 elements to LLM, we generate a response and send it back to the user. So I guess this is pretty clear now. I'll explain very quickly again that we have document, we process that document, convert that document into small chunks. For each chunk, we generate numbers representing that chunk, and then the chunk and numbers are stored into VectorDB. User writes a query. We have user's previous message or messages, and with the help of current query and previous messages, which is chat history, we take query, rephrase it, search into the VectorDB, find the similar documents, do some prompt engineering, write a system prompt, context, chat history and query, pass it to the LLM, and LLM will generate the response. So this is the whole structure. Now let's look into vector data store. There are numerous vector data store solution available. FICE, ChromaDB, FICE, Facebook AI similarity search. This is very popular, free. One is ChromaDB, I guess. Yeah, ChromaDB is free and good solution. There is Pinecone as well, which is I guess paid solution, but if you want to get started, you can get started with it with a free account, and it doesn't require credit card as well. But since my couple of project and clients work, I've been using this quadrant a lot recently, and it is again a good solution. And with simple 2 lines of code, you can run it locally and use it. So what you need to do is that first you need to install Docker on your machine, and I know that installing Docker on a Windows machine is kind of pain, because you need to manage Windows subsystem for Linux, WSL I guess, but that's okay. So you can install WSL and then install Docker, and then you need to just pull the quadrant Docker image and then run the Docker command, and it will start the engine locally. So obviously I already have done those 2 steps, and let me start my quadrant image. Let's run it. So you can see with the help of the single command, you can start the quadrant client, and you can view the vectors and do more stuff as well. So these are my some previous testing work. You can see the information about that as well. You can take snapshot, even you can visualize it as well. And you can see that it has page 1, page 2, okay, page 4. Yeah. So this is very convenient, but feel free to explore other options. So yeah, so this is set up now. So yeah, in this part, this is ready. It is running at this point. Now first let's understand this part: document, processing and generating embeddings. So I have my Visual Studio Code open, and I have already written the code. So I'm not going to write every piece of code at this very moment, but don't worry about that. We will go through all the things that are needed. So let me first go to this configuration file. Okay, and you can see here I'm reading my environment variables here. At this moment it's only one. Then here all the quadrant setting is there. Let me remove this to some other place. Okay, this is my error message. Then this is quadrant setting. We are creating a quadrant client and using it whenever we need it. Our document type is PDF. In case you want to change to other document type, you need to change it here. I'm reading it from this point. This is my collection name and this is my quadrant URL. Then this is Openai setting. We have embedding function from Openai and chat model from Openai as well. So this is my configuration. One more thing, you need to create a .env file. So this is the example of .env file. We have only one key, Openai API key, and this key, the value will be your key. Yeah, let me look to the streaming in case. Can you give some example of embedding? Is a single store vector DB? I'm not sure, Gyandaryo. Single store. Single store. Yeah, maybe they have solution for vectors. I'm not 100% sure. I was in a conference in Bangalore a few days back, I guess in November, around mid-November, and they had a store there. Single store had a store there, and they showed me one vector store example as well, but I'm not 100% sure on that. And he's saying, can you give some example of embedding? So let's say embedding is let's assume that we have we have huge, let's say, dictionary where each word represents a number. Let's consider this. We have a huge dictionary where each single word represents a number. Now, consider a scenario where you have a sentence, and with the help of the dictionary, you convert the sentence into only numbers. Okay, that will be a list of numbers. So I guess this explains you. So embeddings is a fancy word, but it's nothing less than a list of floating point numbers. And let me show you very quickly. So you see here, so this piece of text is represented by this vector. Okay, this 7, 6, 8 values of vector, and I'm not sure, metadata. Okay, let me copy this, and if I open a text editor, let me paste this. Okay, I hope you can see that it's only numbers, 7, list of number 7, 6, 8 values. Okay, now in this case, when we are going to use Openai has embedding dimension of 1536. Openai embedding dimension, if I'm not sure, yeah, 1536. Okay, so when we run the code, we will have each document represented by 15, or each chunk of the document is represented by 1536 values. I hope I'm clear with embeddings. Happy Life is saying, here are you Openai embedding, is there other? Yeah, there are other embedding function. One is sentence transformer. Okay, sentence transformer is widely used. It is supported by Hugging Face, and yeah, this is widely used as well. Okay, you can, instead of Openai embedding, you can use Hugging Face embeddings as well, and then provide the repository name. So provide this name and it will download that, and you can Lnagchain Hugging Face embeddings, and you can learn about it as well from here. Just when you copy these things, you will good to go, I guess. So this is our configuration. So we are about to do this for thing. So I have this index.py. Let me close all of this. I have this index.py. Here I have one function, create index. So what we are doing is we are loading a directory. So here my document directory is passed to this function as an argument. So I have this folder in which I have one document, and let me show you the document as well. So this is a new paper which is on style TTS2, which is text to speech, and it's a very fine paper, and I have implemented the code for it as well on my GPU, and hopefully in near future I'll be doing a session on it as well. And it was the results were very amazing. It was producing nearly human level text to speech, and it also understands the comma, full stop, and many stuff. So we are going to embed this paper, and then we will ask things about this paper. Now here, so this paper is in this documents directory. So this part assumes that you provide a directory in which it will look for all the PDF file, and then it will load all the PDF file using this PyPDF2 loader. So here I would like to show you one more thing, is that let's say you don't have PDF but you have text file. So instead of this PyPDF loader, you use text loader and change the extension txt file. So that means look for all the txt file into the directory and load those txt file using this text loader. So I guess now you all understand that if you want to change this to documents, then you need to import, I guess, doc to txt loader. So this way you can handle all the different kinds of file. Okay. Then here this is the loader, and loader has a method load, which will load all the documents into this documents variable. Then we will generate a text splitter. So obviously that document will have let's say 5-10 pages. So if we don't split those 5 or 10 pages from the documents, then we will need to, if you look here, we will need to move all the content into the context, because whenever we search something, all the pages will come as a single search. So that's why we will convert or split that into small pieces of chunk, and this chunk size will be 1024. So each document will have 10, means each piece of the document will have 1024 size, and this overlap means let's say here the first document ends, so include some words of the previous document into next document chunk. Then we will split the documents using this splitter, and this will convert the document into small pieces of text. And then with the help of quadrant from Lnagchain, we will pass the text. We will use a method of that class. From document we will pass the text embedding function, collection name, and the quadrant client URL to this thing, and it will store all the text into vector db. So let me save this. I guess there is no mistake, and our quadrant client is running as well. And here let me make sure I'm in the correct folder. Yeah, I'm in a correct folder. Let me clear the screen, and let me, yeah, and before we move forward, obviously you need to my bad you need to create your virtual environment and activate it. So I guess I have created my virtual environment. Yeah, it is there. So I'll say source venv bin and then activate. So now I'm inside my virtual environment. Now I guess, yeah, I have a file called create vector db. Here I'll call the function create index, and I'll pass the folder name in which I have stored all the documents that I want to convert into vector. So let's run that. So I'll say python create vector db. So when I hit it, it will do all the things. Yeah, document is loaded, and hopefully it will convert that into vectors. And let's, yeah, so you can see that documents are uploaded and index created successfully. So if I come here and go to my all collection, you can see this rag database is created, which is coming from here. My collection name is rag database. So if I go here, you can see that now the vector length is 1536, cause we have used Openai embeddings, and it has length of 1536. So this piece of document is represented by this 1536 numbers. And let me come here. So I have total 64 those kinds of document. Okay, and you can see it here. Okay, all the documents. Also there will be metadata as well. So this metadata says that it is coming from this thing. Okay, so yeah, I guess now you understand creating vectors. So we have now created our vectors successfully. So this part 1 2 3 and 4 is complete. Now let's look into this user writing something and doing this part. Query rephrase the question, search into the DB, and create context. Meanwhile, let me very quickly look into the comments. The TTS would be very cool session. Yeah, sure, Miguel. I have successfully ran it, and I'm going to do a session on that. So watch this space. Now, so we have created our indexes or vectors. Now, let's look into how to handle the conversation. So we are going to first, let me show it here. We are going to build Gradio web UI. Okay. So when you build Gradio web UI, you will have a chatbot element, a message, text box, and a button. So this chatbot will be a list where each element of the list is a list, and it has two elements. First index is the query, and second index is the assistant or bot response. We will come back to this, but why I showed it will be clear in a few seconds. So in this conversation.py, we will handle all these part: query, chat history, rephrase, search into document vector, and then creating context. So this is my main function, create LLM conversation. This is my main function. It will receive a chat history provided from this front end, Gradio front end. So that's why I said that this chatbot element will be a list of list, where each element of the list will have two things, on 0 location query, and on 1 location bot response. So we will receive this chat history, and it is a list of list. Yeah. So we'll receive the chat history. So the first thing we will do is that get the last conversation and take the 0th element. So the last conversation is the one where user has written his query. So we get our query. Now we are creating this vector DB again from Lnagchain. We provide the client, provide the embedding function, and provide the collection name. Now here is my system prompt. As you remember, we have system prompt, context, chat history, and query. So I'm saying that you are a helpful assistant. Use the following piece of context and chat history to answer the question at the end. Keep all the answers short and concise. If you don't know the answer and the context doesn't contain the answer, truthfully say, I don't know the answer, maybe. Okay. And I have written like keep an informative tone. And I have instruction, context, chat history, and question, which is, I have put against the human keyword, and AI will be the response. So I'm creating this template, and with the help of chat prompt template from Lnagchain, we will create our prompt. So this is the prompt part. Now we will create our large language model chain from again Lnagchain, provide the chat model prompt, and I have written verbose true. Now you can see here I'm condensing the user's query. So let's look into here. So for condensing the user's query, obviously we are going to use the LLM, and I have written that given the following chat history and a follow-up question, rephrase the follow-up question to be a standalone question in its original language. keep the context of the chat history in the standalone question, and then I provide the instruction that chat history is the chat history we provide, and question is the question we provide. I'll form a template, again chat prompt template from this string template, and I have just written a small catch here. So many times I was facing that when you just write hi or something else, it was, since there will be no chat history, so it was converting the question into some unusable thing. So I have written that if the chat history has one length, means it is second or greater than the second conversation, then go forward, otherwise return the query as well. So I'm formatting the chat history. So let's look into this. So this chat history will have one small thing to understand, that the last element of this list, chat history, will have a none value, and you'll understand that in a bit. So that's why I'm just discarding the last element of the list and then formatting the chat history. Human has said something, AI has replied with this thing, and I just format that. So formatted chat history, and then we'll create our LLM chain, and we provide the chat model prompt, then get the response, just clean the response and pass the standalone question from this condense user query function. So we got the condense user query, and let me print the query here as well. Let's say user query, and I'll put query there. Okay, now we are here. Yeah, so we have condensed our question with the help of VectorDB. We search the similar document, provide the query, got the searched document, then this is format the chat history as like this. Then we will format the context. So the context will be a list of Lnagchain documents, and it has bunch of information. Out of those information, we have this page content, which is useful, which is the content of so let me show you here. So when we find the document, we will get this metadata and page document and other stuff, but out of those things we only need this page content. So we will take that page content and append into this formatted context string, and we'll return that. So here, this part, we format the context. So now you can see here, we rephrase the question, search the VectorDB, and formatted the context. Now, since you already know that we have a system prompt and instruction, and based on these three things, we create our prompt. So we have created our prompt. Now the next step is to pass these information to LLM. So when we create this LLM chain and provide the prompt, we can pass these things as a variable, these things: context, chat history, and question. So when you pass these things, it will format the string, and I'll show you as well. Now, and the formatted string will be passed to Openai, and Openai will generate a response. We'll clean the response. Since we are using Gradio, I'll append the response into chat history in the last element, and we'll print that, and we'll return the chat history. So this is how it works. it was not that it's not that tough. If you remember these things, we have query, chat history. With the help of query and chat history, we rephrase the question, search into the documents, find the document, create a context, and create a prompt. So this is our main function. Let me save this as well. Yeah. Now, let me look into the okay, there is no comment yet, so I guess I'm moving pretty fine. Now we have our conversation.py ready. Now let's look into this Gradio UI, which is very simple thing. We are creating blocks in which we have 3 elements: chatbot, message, and clear button. Whenever message is submitted, first handle user query. So if you are new to this Gradio web UI framework, then I suggest you should look few of my videos on this. But what happens is that when this message is submitted, these two things, so message and chatbot element, is passed as input to this function, and this function will again return message and chatbot element, which will be replaced which will replace these two element. So if you look here, I have handle user query, which receives these two things, and it will append a new list into the existing chat history. The message will be query and the response is none because we haven't generated the response, and it will return empty string so that the message text box will be cleared and the chat history. Okay, let me look into this comment section. Again, hi everybody. Now once this is done, then go to create LLM conversation, pass the chatbot element, and this function, as you know, will return the chatbot element again, and which this will replace the existing chatbot, and will queue the demo, which is this blocks. Now in order to run all of these things, we have this run.py. Here we'll create a fast API application, and we will mount the Gradio UI into this application, and it will be served on /Gradio URL. So let me come back here. So we just looked into this part. User writes a message. With the help of Gradio, we will save and retrieve all the previous messages. So now, I'm in my terminal, and I'll say UVCon fast API applications can be run using UVCon, and I'll say run. This is my file name. Mount my file name as application, and I'll say -- reload, so that in case I make any changes to any of these files, it will reload the server. I'll hit enter, and you can see that the application is running on this URL. So you can see that we got a message, Gradio UI is running at /Gradio, and I'll say /Gradio, and it will open a nice UI. So this is our chat bot element from the UI. This is chatbot element, and this is the message, and this is clear button. So whenever I write anything here, it will first go to handle user query. So that means just set the user's message into the chatbot element, and once it is set, then go to create LLM conversation, get the bot response, and show it to this chatbot element. Hopefully, fingers are crossed. I haven't checked it, but hopefully, yeah. So you can see that when I hit enter, this hi was written first, and this was a bit later than this user's query. Let's say, can you explain style TTS to me? And there is, I guess, typo YOU. Now this style TTS paper has came very recently. You can see November 20th November 2023. The latest version of Openai is trained on the data of, I guess, September 2023. So why I'm saying this? Because it will not have the knowledge of this paper. So now if I hit enter, yeah, we got the response. Style text to speech is a technology that converts written text into spoken. It is often application. Yeah, and you can see that it has understood the style part as well. Okay, and it's saying that making the speech more natural and expressive. So if we look into the terminal, here are the things. You can see that the first thing, we are condensing the question. Okay, condensed query. You see, I have written, can you explain style TTS to me, which is converted into this, could you explain what style TTS is, which is, I guess, more formatted. These are the documents which we found in the similarity search. Then with the help of chat history query, this context, we have formatted the prompt. So you can see this is our system prompt. You are a helpful assistant. This is context. So these are the context. Okay, this was our chat history. Hi, and AI said, hello, how can I assist you today? This is the current query, and AI has responded with these few lines. So I guess this is it. I have made my point. So this is this is very fundamental of retrieval augmented generation. There is nothing which is out of what we have just seen today. Okay, there is nothing out there. So I guess this is pretty clear to everybody. And let me just push the code to my GitHub so that you all can get that. Not pushing env PyCache. I don't need these things. I guess I need documents to not be pushed on GitHub. I have requirements. I guess everything is fine. So I'll push the code on GitHub. Let me see if anybody has question. Okay, if we use Palm API, we need to change embedding also, right? No, I guess you don't have to do anything because Openai is, I guess, replaced by Palm. Happy Life is saying, instead of Openai, can we use Palm API or Hugging? Yeah, you can use any API. So I hope now you understand that you can pass this thing to any system and it will generate a response. Obviously, this is text, and the LLM needs to understand this text and generate a response. So you can use any LLM. Okay. I guess there is no new comments. So I guess this is it from my side. And let me ask, who are the authors of this research? Hopefully we'll get the correct answer. I'm not sure on that. Oh, I'm sorry, but the context doesn't provide more information on authors of the, yeah, because if you look here, you know, this is now the limitation of the of the LLM, because you can see here these are the authors. Okay, the authors are there. These are the authors. Okay, these are the authors, but the LLM is not able to understand, you know, that these are the authors. So this is kind of a limitation, but you know, with the advancement of LLMs, it will surely going to understand that, and we will have, you know, very efficient retrieval augmented generation. Let me push this to GitHub. Let's say it's my first commit. I'll commit everything, I guess. Okay, I'll publish the branch, and I'll say YouTube live on today is 09/12/2023, and it is about introduction to RAG. Okay, and I'll publish this. Let me see if it came. Let me refresh this. Yeah, it is here. Okay, I'll paste the link into the chat as well. Okay, someone is saying to recommended product based on our user response. Yeah, you know, now you can implement this knowledge of retrieval augmented generation into anything. I hope now you are clear on this. Okay, so yeah, it's pretty much an hour. I'm still open, you know, 1 to 2 minutes. In case you have any question, you can drop them into this comment section. Let me add a readme file here as well meanwhile. Okay, let me save this. I'll update the readme and push the changes. Let me see if someone is asking. Yes, got it. Can you on some level overview an architecture? Yeah, so this draw.io file is there in the GitHub repository, so you can, you know, look into this and understand. Now I hope you understand, you know, the future scope is, let's say you connect the same system whatever I have built on top of Gradio, and we are just viewing it into this web page. You can, you know, connect it to WhatsApp, let's say Facebook Messenger, any messaging platform, Telegram, Slack, anything. Okay. For image data we need to create embedding. You know, for image data, what you can do is that OpenAI has visual API. You pass the image and ask the OpenAI to explain the image. Once the image is explained, store that information and use the text version of the image into the chat. That will help as well. Yeah, I guess this is it from my side. If you face any issue running this repository, please let me know in the comment section. Also, I would like to showcase my community. I have a community on chatbot development, and things revolved around chatbot development. This is my thing. I should not be showing this view as a member. So this is my community. Learn everything about chatbots, and spread the words. Okay, link is copied and I'll paste it here as well. Yeah, you can join my community. I'll be posting stuff around chatbot development, Python, Node.js on my community, and when you join this community you will connect to me through WhatsApp community chat, and you can reach to me directly as well. So I guess this is it, and I'll stop. Please put this link in the chat. Yeah, sure, I'll do that. Okay then, good night everybody. Peace.